Bow your heads, please.
Dear Heavenly Father, Lord, thank you for this day. Thank you that we have science class. Please help us to absorb the material. And please help us honor and glorify you with our thoughts, words, and actions. In Jesus' name we pray. Amen.
Amen. Good prayer. I like that. All right, you have your test out. Test for Module 4. Let's go over that quickly. Electrolysis. You should have said something about cutting with electricity. Yes, good. Polar molecule. Hopefully you said something about unequally shared electrons. Yes, Bug.
I said negative and positive charges.
No, the uneven sharing sets up a fractional charge, but it's not a real charge. Remember we talked about that?
I also said slight negative and positive.
Slight negative and positive.
That's what I said.
Okay, that's fine. That's fine. Okay. But guys, remember that it's uneven sharing that causes those slight charges, okay? All right, and then the next one is solvent. You could have said the thing doing the dissolving or the dissolver. Solute is the thing being dissolved or the dissolvee. Cohesion is the that things stay together even when there's pressure on them. Hard water, you should have said something about it has ions dissolved in it. And if you wanted to say particularly calcium and some other things, but right, but you didn't have to. It's something about the water has ions, or you could have said little pieces of rock in them. I'd have been good with that too. Okay. Number 2, what is the chemical formula for water? Oh my goodness, what's the chemical formula for water? H2O, thank you. Number 3, some metals tend to absorb oxygen but not hydrogen. Suppose such a metal was covering the battery in the electrolysis experiment like experiment 4.1. Oh boy. Okay, which is the more likely erroneous result the experiment would yield for the chemical formula. So we have our little experiment with our test tubes on it, and we have the metal covering the battery. Some metals absorb oxygen. It absorbs oxygen. If it was going perfectly, it should look like this, right? But it's absorbing oxygen, so that means it'll end up looking like what we really got. Anyway, so instead of being H2O, they're asking you, is this HO2 or is this H4O? Which one would that be?
H4O.
Yeah, it looks like there's more hydrogen than oxygen, so the answer would be H4O. Hopefully you guys did that. I personally would have drawn that before I tried to answer that question. I hope you guys did whatever it takes to help yourself. Okay, number 4. Why is water a liquid at room temperature when all other chemically similar substances are gases at room temperature? I love it. She says they're holding hands. Hydrogen bonding. You could have said both. I would take it. But the correct answer would be hydrogen bonding. Thank you. Number 4. Why is water, oh, we just did that, sorry. Number 5, carbon dioxide is one of the gases we exhale when we breathe. Carbon monoxide is a poisonous gas associated with burning things under conditions of low oxygen. How many atoms are in one molecule of CO2? You guys tell me. 3, very good. How many atoms are in one molecule of carbon monoxide, CO? 2, very good. So your answer was 3 and 2 and number 5. Number 6, an important component of gasoline is octane, which is composed of a molecule that has 8 carbons, 18 hydrogens. What is the chemical formula of octane? Go ahead. Go ahead.
C8H18.
Good. C8H18, just in case anybody needs to see it. C8H18. Okay? That's what it should look like. All right. Number 7, why are water molecules polar? They're not sharing evenly. Guys, everybody say uneven sharing.
Uneven sharing.
You got to remember that. Uneven sharing. If they're unevenly sharing the electrons, there's going to be a slight charge over the molecule. Okay? Good. Because remember we saw that the oil went straight? Remember that? That had even sharing. That was a purely covalent or a nonpolar molecule. Nonpolar because it shares evenly. That's why it didn't go towards the balloon. Whereas water is polar and therefore it shares unevenly, therefore it has a slight charge over it. That's why it went towards the balloon. We are up to number 8. If a substance does not dissolve in water, is it most likely ionic, polar, or nonpolar? Everybody? Nonpolar, thank you. Because the other two are charged particles and therefore it can grab hold of them. Number 9, if a substance dissolves in water, will it dissolve in vegetable oil, a non-polar substance? No, thank you. It's like being at a concert or something, you know. Get an answer. Number 10, is hard water the result of cities' water treatment process? No, it's got to do with the rocks the water moves through, correct? And we're going to talk more about that today. Okay, so each one is worth 10, 11, 12, 13, 14, 15. There were 6 points apiece. If you missed one, take off 6 points. Because it doesn't quite make 7. So remember, you're not adding up. You're subtracting whatever you missed from 100. It comes out better for you that way, trust me. And each answer is worth 6 points. Okay? Okay, let's put that away and get out Module 5. We are looking at the hydrologic cycle in this chapter. So we're getting ready to start studying weather, but we are building our way up to it so we have some background. And in this module, we have a couple experiments that I did not assign, but I wanted to try to do them today for fun. So we're going to do them together. So we're going to start them now because it takes a little time to get them set up. And so on page 109, experiment 5.1, what we're going to try to do is actually evaporate, condense, and precipitate water. And to do that, and I'm not sure that this is going to work, but we're going to try it. And the only reason we have even a hope of trying it is because I'm also the chemistry teacher and I stole things from the chemistry boxes. No, I didn't steal them, but I borrowed them. Okay, here I've set up the experiment where we have salt water and we're going to try to boil it off. And here's our bowl. Here's our lid that we're going to try to catch it. And I have a bag of ice that we're going to put on here once it gets down to that point. And so we're going to see if we can distill the water like the experiment says. All right, so let's go back to the beginning of the chapter. That's going, oh, there was one other one that we should probably set up in advance. And that's on page 116, 5.2. And I have already set up, you guys were supposed to have read these. You didn't have to do them, but you were supposed to have read them. I already set up the salt water in a bowl, and it's freezing in the freezer. It's been there since 8 o'clock this morning. So, and for those of you that are home, it's like 3 hours ago that I set it up. So hopefully it's not solid already. Anyway, we'll figure it out. Okay, and I also have some ice cubes for you, and you have a plate in front of you, and you have a little thing of salt. I'm going to go get each of you an ice cube, and I'm going to put it on your plate. There's one for every 2 of you, so that should be your 2, okay? And you are going to very carefully find a flat side to the ice cube, because these ice cubes have holes in them. That's how the machine makes them. So don't use the holy side. Use the flat side, and you're going to pour a little pile. You don't have to use the whole thing of salt. Pour a little pile of salt on the flat side of the ice cube. We're going to go ahead, and I'm going to do this part of this experiment now. What I have in here is salt water that has been in there for 3 hours. And what we're going to do is we are going to strain the ice out of here. Yeah, we're straining the ice out of here. Okay? And then we're washing the ice with fresh water so that we know that we've rinsed off any exterior salt that could be in there. Okay? And then I'm going to pour it into a cup, because we are going to let this ice melt in this cup, and we're going to taste it and see if it's salty. Okay? So that's part of the experiment that you're doing with the ice. So now we've frozen got it slushy at least. It's been 3 hours and it's only slushy. But anyway, we've frozen the salt water. We rinsed the ice. We put it in here. We're going to let that melt, and we're going to taste it. Okay? So far, so good. The other half of that experiment is that I'm going to give each of you an ice cube. And like I said, you're going to do your salt thing. Oh, my goodness. You weren't allowed to do that. Okay, here. Okay, did you already put your salt on?
Yeah.
Yes? Okay, then just set it aside. And we're going to look at that in a couple minutes, okay? 3 things going on here that I have never done in class before, and I've taught this class for it's over 20 years. That's really scary. It makes me feel so old. I actually taught out of the first edition of this book. That's how long ago. This is the second edition. Okay. Let's go ahead. We'll see, these experiments are hard to do because you have to set them up in advance and you need the freezer, blah, 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 blah. But because I have a little kitchen right over there, I was able to do it. It's like cheating, isn't it? Yeah, okay. Plus, I came in here 3 hours before this class, so I was able to set it all up. So I figured we could try it, right? And we have an ice machine.
Yay!
Yay! Jehovah Jireh, praise the Lord, right? Okay. Anyway, if you don't know what that means, it's God our provider. So let's let it go. All right. So we are on page 105, and we're looking at the hydrosphere. And the hydrosphere is how water moves from one place to the other. And if you turn to page 106, well, 105 has a lovely picture of Earth from outer space, doesn't it? And you see that the planet is covered by mostly water. It's like 72% water. Yes, and those of you that are good at geography can figure out the things you're looking at, and that's great. She just said Madagascar. So turn to page 106, please. The hydrosphere is all the water on the planet. That includes in any form that it might be in. Remember that water can exist in solid, which we call it an ice, liquid, we call it water, and the gas form, which we call water vapor. But it can exist in all 3 of those forms, and because we have liquid water on planet Earth, because of that, we can have life on planet Earth. God very clearly designed water such that it would be liquid enough of the time on this planet that life could exist here. Water has all sorts of weird properties. We already talked about that in the last chapter, how it's got hydrogen bonding, how it's liquid more of the time because of the hydrogen bonding, because you have to shake loose those little bonds from each other, the holding hands, to freeze it or to make it go into the gas stage. And so it's very, very special. And that's why life can exist on this planet. But the trick is this. This is the only place that we see liquid water anywhere in the solar system. So why is water able to be liquid here but not in other places? Do you remember from reading? Yes.
Because the Earth is a special distance away from the sun.
Okay, and what does that distance do for us?
Gives us the right amount of heat.
Temperature, very good. Our temperature, remember the average temperature on this planet is 50 degrees Fahrenheit, even if you take into account the poles. That's pretty pleasant, right? And then, so the distance from the sun, and what other thing helps keep the warmth at 50 degrees Fahrenheit? It is the distance and the atmosphere. Very good, the atmosphere, which has greenhouse gases in it. Very, very good. And so those are the 2 things that actually keep the planet at the temperature so that water can exist in a liquid form here, whereas we don't see that anyplace else in the solar system where we actually find water. And then remember, we talked about this before, that water exists as liquid between 0 Celsius and 100 degrees Celsius. Most Americans don't use Celsius though, so we said between 32 degrees Fahrenheit and 212 degrees Fahrenheit. It's a boiling point. This is your freezing point, right? Okay, so that is a big range, and that's a great thing. Now, the water on planet Earth doesn't stay... Is everybody okay? I heard a beep. Okay, so you're okay. All right. The water doesn't stay separate from all the other water on the planet. The water actually moves from one source to the other within the hydrosphere. And on page 107, he tells us that... first off, you're going to tell me, we're going to go over the things you really have to know, that you have to have memorized. Where is the vast majority of the water on planet Earth?
The ocean.
The oceans. You can see it from outer space. First off, are we seeing anything there? Are you starting to see a hole in your ice cube? Yeah? Where's your hole? Right here. There it is. I can stick my finger in the hole. Are all of yours like that? We did see that you've got a hole in your ice. We're going to come back to that. All right? Okay. Let's go back to this. Where is the most fresh water on planet Earth? Because the water in the ocean is salt water. We know that. Where is the most fresh water? Good. Glaciers and icebergs, right? Fresh water. Wow. Do we think of that? Do we have that issue here? No. Where is the most fresh water that is in a liquid form? Everybody. Groundwater. Okay, you have to know that. And so the three bolded points under table 5.1 is the vast majority of the Earth's water supply is contained in the oceans. It's salt water. The vast majority of the fresh water is in icebergs and glaciers. And number 3, the largest source of liquid fresh water is the groundwater. Okay, you have to know that. And so how the water moves from one of these places to another is called the hydrologic cycle. And it's pictured for you on page 108, but it's also pictured up here because it's something everybody is supposed to learn. Everybody's supposed to learn the hydrologic cycle. We're going to get this boiling. We're just not going to give up, okay? It's trying really hard. Okay, so let's say we have the most water here. And the only way water can get out of the ocean is how? Besides you going down there like Elisha did when they were... when he was fighting with the Baal, Elijah, when he went up and fought with the guys on Mount Carmel, the Baal, Jezebel's priests to Baal, remember? Well, they were on the ocean. Didn't you ever wonder where they got all the water to put on his offering? I did. I asked that question. It's like, wait a minute, they're at the end of a 3.5-year drought. Where's he getting water to dump all over this offering? Didn't you guys ever ask that question? And he was right. It's right on the water. Mount Carmel's right on the water. So they went down and got the water out of the ocean and dumped it on there. But anyway, that helped me with that story. But okay. Then I was like, oh. You guys know the story, right? And then the other guys couldn't call down the fire, and then Elijah goes, let's do it, Lord. It's all gone, licks up everything, water and all, just woohoo! You know, it's like, go, God, go. Yes? It's got a hole all the way through. Oh, that's cool. Can I show? Let me show the kids at home. I love this. This ice cube actually has a hole all the way through. So there's a hole that goes straight through it now from the salt. Very good. Thank you. That is so cool. Is everybody else's that far through?
Yeah.
Very cool.
It turns out.
Cool. Okay.
Ours just fell apart.
That's all right. We're going to get there in a minute, but we did the experiment, so we'll talk about it in a minute. Okay, let's go back to this. So the water can get out of the ocean either by people bucketing it out like we were just talking about, or what's the other way it can get out of the ocean? Evaporation. If it evaporates, it goes up into the atmosphere, turns into a cloud, which is called condensation. So evaporation is taking a liquid and converting it into a gas, whereas condensation is the opposite. It is taking a gas and turning it back into a liquid. Makes sense, right? Now, if this one absorbs energy so that you can get dancing molecules to be bouncing off the wall, guess what this one does? Releases energy. It actually releases energy because it's wanting the ones bouncing off the walls to mellow out enough to start dancing. Does that make sense? So there's actually a process of releasing energy into the atmosphere when condensation occurs. We're going to talk about that more next week. Once the clouds exist, then there are currents in the air that either it will rain out over the ocean, and if it does, it just keeps doing the same thing over and over again, or it can be pushed inland, and then it will rain out over the land. Once it rains out over the land, it can do a couple of different things. If it just rains on the ground, and there's no lake there or river or anything like that, then the water will go into the ground, and it can either become soil moisture, so it's right there in the top part so that the plants can suck it up. And let's say the plant does suck it up. If the plant sucks up the water because it was soil moisture, then the plant actually evaporates it back into the atmosphere through its leaves in the process of photosynthesis, and it's called transpiration. Now notice here it's called evapotranspiration. It's just using the word transpiration and adding the evaporate into it, okay? Transpiration is evaporation from plants. And the way I've always told my students to remember this is when people lose water, we perspire. When trees lose water, they transpire, okay? And that's how I remembered the difference. People perspire, trees transpire. They sound very similar though, don't they? Because it's very similar things. They're losing water to the atmosphere. Okay, now let's say though it gets into the soil and a tree or a plant doesn't suck it up and transpire it back into the atmosphere. Then it might actually go down into the ground and turn into groundwater, and then it will move back towards a river or a stream and move back towards the ocean. That's what the groundwater does. if there is a lake or a creek or something, then the water, whether it be soil moisture, whether it be groundwater, or whether it be right off the top from the rain, it'll gather into lakes or streams, and it will head back for the ocean. All that water, and it's interesting because the book pointed out that that's in the Old Testament, way before anybody was doing scientific evidence on this, and it described the hydrologic cycle perfectly, and people that don't know the Bible's God's word and true go, wow, look at that, look how smart those guys were. And I'm looking at it going, well, they had the boss telling them what was right, you know, and God's word's perfect and true, and every word in it, you know. So anyway, so we have the hydrologic cycle, and you notice that these water sources are not separate from one another, are they? They all take turns being one place or the other. The ice is cooling the lid, which allows the water to condense on the lid, and then it gathers in the bowl, and then as you taste the water in the bowl, it actually is fresh water, because as you can tell, the salt is actually left behind, and I'm hoping to not burn myself, but if you'll look, you can see the salt in the bottom of this beaker. You see it? And so the salt is left behind, the fresh water goes in here, and that's how distillation works. When the water comes out of the ocean through the process of evaporation, if we continue to let it burn, eventually the water will evaporate off and the salt will be left in the beaker. Literally. It'll be full of salt. And if it does work while we have class, I will actually catch some of it by using the top of the pan and the ice cubes, okay, which I have a little bag of ice cubes over there, and then we would taste the water. Now, you guys tell me, what would the water taste like if we did that?
Salty.
Actually, that would be fresh water. That's distilling it, because in the process of the water evaporating, it leaves the salt behind. And just like I can get the salt all over the cup, the water is the only thing that's boiling off. And so it leaves the salt behind, and then when you catch it through condensation, it becomes fresh water. That's why fresh water rains out of clouds, because it comes mostly out of the ocean, but it's fresh water because as it evaporates, it leaves the salt behind, and it evaporates into the clouds, and then it precipitates out on us in the form of fresh water. So far, so good? Yes, Grant?
I can't see it.
It's okay. There's nothing to see at this point. Okay, so we said transpiration was evaporation from a tree or a plant. Condensation was turning the gas back into a liquid. And precipitation is water falling from the sky. Okay, now I want you to know that in general terms, precipitation is anything that falls out. Like if I put too much sugar in my iced tea, and as I'm putting it in and I'm stirring it, there's sugar falling out, that's actually a precipitant. It's precipitating out. So really, anything that's falling out of something is a precipitation. But with the hydrologic cycle, we're specifically looking at water falling from the sky in some form, aren't we? I used to like to say that if my little brother was up in a tree and I shook the tree hard enough, I could precipitate my little brother. But don't do that. Don't go home and say, I want to precipitate you now. You know, that'd be mean. Okay. No, don't try that with your little brother or sister. It would be mean. Okay. Anyway, so if this experiment worked, and if we were able to boil this off, and we were able to catch this water so that it condensed on here, after evaporating there, condensed on here, and caught it here so it would precipitate out here, and we tasted that water, that is what distilled water is. That is the distillation process. When you evaporate, condense, and precipitate something, you are distilling it. And so you get distilled water, which is water with basically nothing in it. I just want to throw this out to you. Distilled water is not good to live on. Don't live on distilled water, because God meant for us to get minerals in our water. And I've known people that lived on distilled water and their kidneys eventually gave up because they weren't getting enough minerals. So that's why I notice most of you, if you buy a bottle of water, it'll say mineral water, and you're thinking, it doesn't taste salty to me. Well, it's because the concentration is so low. But it does have some minerals in it, and that's good for us. You want the minerals, okay? Just so you know. So this experiment we just talked about, even though it's not working, maybe that's why I've never done it before. But I thought I'd try. Okay, on page 111, he tells us the point of the experiment was to show you how distillation works. And you see the vocabulary where their distillation is evaporation and condensation of a mixture to separate out the mixture's individual components. And so you've probably heard of somebody in the backwoods having a still and they're making moonshine. Okay, you ever heard of something like that? All right. A still is the short version of distillation. What they're doing is when they ferment, let's say they're making corn liquor, which is I think what they used to do. And so you have the sugars in the corn go through an anaerobic process, which means think of it, it's a fermentation process, kind of like kombucha or sauerkraut, okay? And as it's fermenting, it makes alcohols. And if you just drank it that way, it would be like drinking beer or wine. It wouldn't be that strong. But they don't want to stop there. They want it to be white lightning and kill people, okay? And so what they do is they distill it. And the trick is, you guys probably all know that alcohol evaporates much faster than water. If you rub alcohol on yourself, it gets cold really fast, doesn't it? And that's because it evaporates so quickly compared to water. So what they do is when they have this mixture of alcohol and water and it's in solution, how do you separate it? Well, they cook it. And when they cook it, the alcohol evaporates off at a much lower temperature than does the water. And so what they have is a situation where they can catch it, okay, and then it comes out over here and it goes in a bottle. And what they do is they evaporate off the alcohol and it comes off sooner, so the water's left behind, and they catch it over here by evaporation, condensation, and precipitation. And that's how they actually concentrate it into that terrible stuff that kills people. Okay, and I mean that. You stay away from moonshine. It's really, really bad for, people used to go blind drinking moonshine. But that's actually how they distill hard liquor too. That's why in the Bible you see Jesus working with wine, but you don't see him serving Jack Daniels or anything like that, okay? Because those are all distilled liquors, and what you've done is you've unnaturally concentrated the amount of alcohol in that, and that's why people get in so much trouble with it, because it's a very unnatural. And I'll tell you something else. The fermentation process with natural yeasts that make wine and stuff like that, they die after they make something like 6% alcohol. So what they've done is man has genetically engineered yeast that'll go up to 12% so they can get more alcohol in the thing. At Jesus' time, you'd had to work, you'd probably make yourself almost sick to get loaded on the wine at Jesus' time because you'd have to drink so much of it. Does that make sense? So yeah, the wine then was different. It was much milder. So anyway, distillation.